Hello. Today we're going to be talking about pulleys and their relationship to kinematics. You have a system with a pulley at rest holding two large pianos inside crates at an incline with a 32-degree angle. The mass of each piano in the crate is 150 kilograms. The coefficient of kinetic friction is equal to 0.4 and the coefficient of static friction is equal to 0.6. The length of the incline is 20 meters and the piano 1 is located on the incline 5 meters from the top. Part A. The string is cut near piano 1. What is the final velocity of piano 1 in the crate when it hits the flat surface? Part 2. The piano then falls off the edge of the flat surface and drops 35 meters to the ground. At what time would piano 1 inside the crate hit the ground?
Question, we know that piano 1 is located 5 meters from the top, but the total length of the incline is 20 meters. This means that the change in x on the incline from piano 1 to the flat surface is 15 meters. For this question, we will also define the y-coordinate as positive upwards, so gravity will be negative when we're solving the problem, and change in y direction of the drop will be negative 35, because we will define this point as 0 and the bottom at which it hits as negative 35 meters. And so change in y will be defined as negative 35.
So the first step in solving this problem is to draw a free body diagram labeling all the applicable forces. In this case, we choose to label the axes in respect to the crate. The next step is to find the net force being applied on the crate. And as you can see here, mass is canceled out on both sides. This leaves us to solve for the unknown variable of acceleration. To do that, we first solve for the acceleration in the x direction of the crate and subtract from the acceleration of kinetic friction. To find the acceleration of kinetic friction, we would find the normal force of the crate, which in this case is equal to the force of gravity in the y component. And after the calculations, we find that acceleration is equal to 1.87 meters per second squared.
One misconception in this part of the problem would be the use of static friction instead of kinetic friction. Because the string was cut, the crate holding the piano is now in motion, making the friction kinetic instead of static. And as you can see here, when you use static friction, you'll get a different acceleration than what you would if you use kinetic friction, which is the correct answer. Another misconception is the use of force normal instead of mg cosine theta. Force normal would only be used if the object was on a flat surface. But because the object was placed on an incline, force normal is now equal to mg cosine theta, which is the y component of force of gravity. You can see here that when you use the incorrect force normal, you get an acceleration of 1.3 meters per second squared. However, when you solve it the correct way using mg cosine theta, you'll see that acceleration will be equal to 1.87 meters per second squared. Another misconception would be when calculating V final. Students may believe that the crate holding the piano contains an initial velocity. However, because the piano was at rest when the string was cut, the V initial would be equal to 0.
After finding the net acceleration of the crate, we substitute into one of our kinematics equations to find the final velocity. And after calculations, the final velocity is equal to 7.5 meters per second. To solve for the second part of the question, we use another kinematics equation to solve for time. After substituting the known values and calculating, we find that the time that the piano touches the floor is 2.67 seconds.
Finally, a misconception could be plugging in the acceleration and velocity solved in part 1. This acceleration found was in the x direction, however the problem is looking for acceleration in the y direction. Because the crate holding the piano is simply falling off the ledge, acceleration in the y direction is equal to negative 9.8 with y positive pointing upwards. And because velocity is not in the x direction, we cannot use the previously solved x velocity. The object is in free fall when falling off the edge, so the initial velocity in the y direction is now 0. And as you can see here, when plugging in the incorrect velocity and acceleration, you will have to perform a quadratic formula, but it will produce no real solution because you'll have imaginary numbers. So using the actual solution, you know you'll get time is equal to 2.67 seconds using v initial at 0 and acceleration in the y direction as negative 9.8.